Okay, so next let's talk about the problem starting computer vision, and we can provide you with a very brief introduction about the problem starting computer vision, and then we can move to the method, how to use deep learning to solve some of the problems. And what are the problems starting computer vision? We have so many different problems to be started in this area. In this page, we show you with some examples, which cover image classification, which is to classify the images into different classes. We have also been studying this problem before with the CM model in the project, right? And we have also been studying this problem in our projects as well, right, with both MLP as well as the CM model for stage 2 and stage 3 respectively. Besides the image classification, we can also start some other problems like object localization. And we localize the specific notation of the objects inside the images. And we can also do object detection and segmentation, which is to do the more precise of the localization of the object and to differentiate the objects from the backgrounds, in the images. And we can also do the detection, to localize objects in the images, to assign them with some labels, right? And then we can also start some other interesting problems for the image style transfer, image colorization, image reconstruction, as well as image super resolution and image synthesis, which aim to change the styles of image from one to another. We also showed you with some examples before, right? And the image colorization want to change the black, white, or grayscale images into the color imaging state. And this reconstruction try to reconstruct the images, from some noisy or dirty image inputs. As to resolution, we want to change the image from low resolution to a high resolution instead. And the last one want to generate some new images based on the inputs or based on styles we have, right? Which is correlated with the style transfer as well as the image generation. Okay, so we can talk about some of them in the lectures, and we want to provide you with some brief introduction only. And you are not required to study all of them in this course, because this area is so broad. You just know some high-level idea, it should be enough. Okay, so first, what is the image classification? So image classification is one classic problem started in computer vision. The image classification want to classify the input images into different classes. Depending on the domain as well as problem settings, we can have different image classification problems. In this page, we show you with some examples. On the left-hand side, we show you with one data set. It's called minutes, right? When we will provide you with this data set in stage 2 and stage 3 already. It's about handwritten number images. You can see the grayscale image, and we have transfer them as either into a vector or to feed them into MLP, or we can apply the CN to learn from them, right? So by the models, we can classify the image from another to recognize the numbers inside them. Now this one will be a 0, and the second row will be the 1, and 4 until we can have a 9 at the bottom, right? So by feeding the images as input to the model, then we can recognize the numbers inside these images by classifying them into 10 different classes. Besides this one, we also show you with another data set. It's called CFAR. We also provide you with this data set in the stage 3 as well. This one is about the small size color imaging stage. So, we can classify the images into 10 different classes. We have airplane, automobile, bird, cat, deer, dog, frog, house, sheep, and truck. So if you check the dataset we provide you in the stage 3, and then you can find some small size images, which is very small actually, and they belong to different classes. And we have a task for stage 3 of the project to classify the images into different classes. There's 10 different classes, right? So by classifying them into different classes, then we can recognize what the image is about. It's about dog, or it's about deer, or some other animal, or some other object instead. So the image classification is a very classic problem started in computer vision, and normally many of the problems they are based on the classification of the images, and we'll show some of them later in the following pages. And besides the classification, sometimes we also want to localize objects inside the images. Not given one image, some of the regions they are about objects, some are not, right? Now in this page, we show you with 2 images, and the first image is about one dog. However, this image is very big. We only have one dog on one part of the image, like this region, right? And the remaining pixels, they are all about the background of the image, like grass and land, right? So if given the image, we want to localize the location where the dog is, then we can have to specify the location, right? By drawing one square box, like this one, right? To localize, to specify the location of the dog inside the image. And the process of locating this dog in the image is called this object localization, right? And on the right hand side, we have another example. Like we have an image about chairs, and we have 3 different chairs. So we want to localize where the chairs are, and so we can differentiate them from one another, right? Then we can draw 3 different like a rectangle, this box, right? And to specify the location for each of the chairs. And it will be helpful for differentiate the chairs from one another, and also differentiate from some other background, right, of the images. Okay, so this is called the localization of the objects. So by combining the localization as well as the classification, then we can do a very interesting task. It's called object detection. So given the images, we want to detect all the objects inside this image, because this image normally will contain so many different objects, right? And we want to specify where the objects are and what are the objects about. In other words, we have to draw both the square box or this rectangle box, as well as assign these objects with some labels. So it combines with both the classification as well as localization, right, to detect the objects inside these images. In this page, we show you with different examples. Now, the first example is about the playground. We have so many persons as well as dog. They're playing, right, with each other. So we can localize where the person is, where the animal is, and what they are. This one is the person, this one is dog, for example, right? And similar for the remaining part of these images in this page. So the object detection is also very critical, also very important problem as we're studying in computer vision. Also, when it comes to self-driving cars, given one image, we have to differentiate the person, the cars, and where the person, where the car is. The location will be very important. Also, the label will also be very important, right? So the object detection is a very classic problem studied in computer vision as well. Okay, so we also mentioned the localization. However, sometimes we want to do a more precise localization of the person, of the objects in the images. Then we have to start this object segmentation. The segmentation, we want to partition the images into different segments, right? Each segment is about one single object, right? In other words, given the images, we want to locate the object and also precisely depict or draw out the borders of the object out, right? To differentiate one object from the other. And in this page, we show you with some examples. Now in the first image, we have many different persons. They are playing together, and they are gathering together, have a party, and we also have one play table as shown here, right? So, to differentiate a different person, we have to draw the borders of each person precisely out. And this part is about one person, this is the second person, and the central, right? We want to differentiate the pixels either belong to one person or to another, or belong to the background state. So the object segmentation is a very challenging problem because we have to generally precisely draw the borders of the objects out in the images, which is critical, however also very difficult as well. So these are some of the examples about the computer vision problems, and we can talk about some more in the next video instead.